In the quiet of night, when we look up and see a sky filled with stars, it is easy to believe that this is the whole universe. A dome of distant lights, a scattered field of galaxies, a cosmic ocean that ends where the darkness begins. But this is an illusion, one born not from the limits of imagination, but from the limits of light itself. Everything we see in the cosmos is bounded by a simple rule: light has a finite speed, and the universe has a finite age. That means we cannot see beyond the distance light has managed to travel since the beginning, 13.8 billion years. Not because nothing lies beyond, but because its light has not yet reached us. We are not looking at the edge of existence. We are looking at the edge of visibility. A horizon, not a wall. Imagine pulling back from Earth, first past the atmosphere, then beyond the orbit of the Moon. The solar system shrinks into a faint disk of sunlight. Farther still, the Milky Way unfurls like a spiral of white fire. Step back more, and the galaxy becomes just one thread in an enormous web of cosmic filaments, vast structures stretching across space like frozen lightning. And then, the view stops. Not because space ends, but because the light does. Beyond that horizon is a realm we cannot yet probe, cannot map, cannot witness, but which almost certainly exists. This is the limit of vision. The visible universe is only a fraction of the true one. A keyhole view into a cosmic cathedral far larger than we can imagine. Everything you see is a story told by light. Beyond the horizon lies everything that has not yet spoken. The cosmic horizon is not the edge of the universe. It is the edge of what we can see. A boundary drawn not in matter or energy but in time itself. When the universe was born, light began its long journey outward. Every galaxy, every star, every atom that existed after the first moments began sending signals through the expanding fabric of space. But the universe has only been shining for 13.8 billion years, and light can travel no faster than its own limit. That means there is a maximum distance from which light could possibly have reached us since the beginning. This distance defines our observable universe. But here lies the strangeness. Because space itself stretches as light moves through it, the true radius of this observable sphere is not 13.8 billion light-years, but about 46.5 billion in every direction. The horizon expands as the universe expands, carrying distant galaxies farther away even while their ancient light continues drifting toward us. This horizon is not a wall. Nothing special happens there. A galaxy just beyond it does not disappear. It simply has not had enough time to send us its story. If we could wait trillions of years, the bubble of visibility would slowly grow. More light would arrive. More of the cosmic tapestry would be revealed. But for now, the horizon remains the ultimate limit of our knowledge. A reminder that we are watching the universe through the narrow window of time, not space. We stand at the center of a sphere of light, an enormous bubble carved out by photons that have traveled for nearly the entire history of existence. Everything outside this sphere is still hidden in darkness, not because it is absent, but because it has not yet spoken. The horizon is not where the universe ends. It is where our understanding begins. The universe is not simply large, it is growing. Every moment, the space between galaxies stretches, carrying them farther apart. This expansion is not driven by motion through space but by the expansion of space itself. And what makes it even more remarkable is that the expansion is accelerating. Something in the fabric of the universe, which we call dark energy, is pushing everything outward faster and faster. Because of this acceleration, distant galaxies are receding from us at extreme speeds. The farther away a galaxy is, the faster it moves. Some retreat so quickly that the light they emit today will never reach us. Not in a million years, not in a trillion. They are already beyond a point of no return, crossing a boundary where the expansion of space outruns even the fastest possible signal. Their light stretches into longer and longer wavelengths, drifting into infrared and then into radio waves, until it disappears entirely into darkness. This creates an unavoidable truth. The observable universe is shrinking in terms of what we will be able to see in the future. Not because space is getting smaller, but because more and more galaxies slip beyond the horizon created by accelerated expansion. Regions of the cosmos that were once visible become permanently unreachable. It is as if the universe is slowly dimming, hiding its outer structure behind an expanding veil. What we see today is only a fragment of all that exists, a snapshot carved from an ever-changing cosmic landscape. The edge keeps receding not because we move, but because the universe itself continues to swell, carrying entire clusters of galaxies out of our sight, out of our reach, and eventually out of our physical possibility to observe. As space expands, the horizon retreats. Not because the universe is ending, but because it is growing faster than light can reveal it. What lies beyond the cosmic horizon is one of the most profound questions in modern cosmology. We know that the observable universe is limited not by walls or borders but by time, by the finite speed at which light can travel. Everything farther away remains unseen, not because it does not exist, but because its light has not yet reached us. And yet physics allows us to imagine what may lie in that darkness. One possibility is simple continuity. Beyond the edge of visibility may stretch the same cosmic web we observe nearby, endless clusters of galaxies, filaments of dark matter, and the same laws of physics shaping structures we will never witness. If this is true, then the universe is vastly larger than our visible sphere, perhaps even infinite. But there are deeper possibilities. The early universe may have undergone regions of inflation that unfolded in slightly different ways. If so, the cosmos beyond our horizon might not mirror our own. There could be zones where the density of matter evolved differently, where the strength of gravity shifted subtly, or where the balance of particles and forces settled into unfamiliar patterns. These would still be part of the same grand universe, yet alien in their physical details. And then there is the most radical idea, that our observable universe is only one bubble in a much larger multiverse. In this scenario, inflation never ended everywhere at once. Instead, it continued indefinitely in distant regions, giving birth to countless domains, each with its own beginning, its own expansion, and possibly even its own laws of nature. Some might resemble our own, others might be unrecognizable. The multiverse remains hypothetical, but nothing in known physics forbids it. We may never cross the cosmic horizon, but imagination guided by mathematics allows us to explore what lies beyond. Whether it is more of the same universe or realms shaped by entirely different rules, the truth remains hidden not by impossibility but by distance. Beyond the horizon may lie a continuation of our cosmos, or a reality shaped by laws we have never known. The darkness is not empty. It is simply beyond our reach. The universe we see is only a fraction of the universe that exists. Through modern telescopes, we can count roughly 200 billion galaxies within our observable sphere, a number that already feels almost too large to comprehend. But this number does not describe the true cosmos, only the part illuminated by light that has had time to reach us. Beyond that glowing shell, far outside the limits of our vision, the universe may contain trillions upon trillions more galaxies. Some estimates suggest that the total may be 3 times larger, or 100 times, or effectively limitless. This distinction between the observable and the actual universe is one of the most important in cosmology. The cosmic horizon is not a physical wall and not the end of reality, it is simply the radius of our knowledge. The boundary of what we can see is set by the age of the universe and the speed of light. Anything farther away remains hidden, not because it is absent, but because its light has not yet arrived. A useful analogy is standing in a dark plane with only a candle in your hand. The small circle of light around you is all you perceive, but the landscape extends endlessly into the darkness. The observable universe is that candlelit circle. The true universe is the vast terrain beyond, silent and unseen. Cosmological measurements show that on scales of hundreds of billions of light-years, space appears flat, meaning its curvature, if it exists, must be incredibly small. This implies that the universe may be infinite, or so unimaginably large that even with a cosmic horizon of 46.5 billion light-years, we detect no sign of an edge. The cosmos we observe is a tiny island in an ocean without apparent boundaries. What we know is only the illuminated part. What exists is far beyond it. What we see is not all that is. The observable universe is only a lit circle in an endless night. Beyond it, reality continues, vast, silent, and immeasurable. As the universe continues to expand, its horizon slowly retreats, not inward in space but inward in what we can see. Every second, more galaxies cross the threshold beyond which their light will never reach us again. The accelerating push of dark energy stretches the fabric of the cosmos faster than light can move through it, turning once visible galaxies into unreachable shadows. In the distant future, this process will become irreversible. Tens of billions of years from now, the galaxies nearest to us will drift beyond the cosmic horizon. Hundreds of billions of years later, only the local group, the Milky Way, Andromeda, and their merged descendants, will remain within view. Everything else will fade into invisibility, not because it ceased to exist, but because the expanding universe carried it beyond the reach of observation. Eventually, After trillions of years, even the memory of the wider cosmos will be gone from the sky. The last visible stars of our merged galaxy will shimmer in isolation, surrounded by an ever-deepening halo of darkness. For any civilization existing then, the universe will appear small, static, and alone. They will not know the truth, that their night sky once held billions of galaxies, each a universe of its own, now lost behind an uncrossable horizon. The cosmos does not shrink, but our window onto it does. The horizon is the fading edge of knowledge, retreating into silence with every passing epoch. One day the galaxies will slip beyond sight. Not because they ended, but because the universe carried them away faster than light could follow. At the edge of the observable universe, our knowledge reaches its final boundary, not because the cosmos stops but because our tools do. Physics itself is built on what can be measured and verified. When light from distant regions can no longer reach us, those regions fall outside the domain of science and into the realm of possibility. The cosmic horizon is not merely a physical limit, it is the border between what the universe shows us and what it hides. Beyond this horizon, our equations continue, but our certainty does not. We can model expansion, infer structure, and extend physical laws into the unseen, yet each prediction is accompanied by the quiet acknowledgement that confirmation may never come. In this sense, the universe contains both the known and the unknowable, regions governed by the same physics, yet forever isolated from our observation by the accelerating expansion of space. And still we imagine. Even without data, the mind constructs possibilities. Endless galaxies, different cosmic conditions, even entire universes beyond our own. These speculations are not failures of science but extensions of it, the natural response of a thinking organism made of stardust, trying to understand a reality larger than light itself can reveal. At the horizon, physics shifts into imagination, and imagination becomes the only instrument left capable of crossing that boundary. Beyond observation, physics turns into imagination. And perhaps imagination is how the universe observes itself.